This is a chip 8 emulator. I can give it machine code, and it will simulate the CPU, memory, and screen to run that game. And it's only one of my 5 favorite C++ projects. Things get super cool later in the video. I start from my high school projects, and number 4 is my own game engine. That's basically different from any other engine you have ever seen online. What could be cooler than that? Starting with number 1, a chip 8 emulator. Chip 8 is basically an old console. An emulator is some computer code that can simulate the internals of this console, like CPU, memory, screen, and everything in between. In this way, I can take the binary of a game, written for it, and I can literally run it on my computer. This literally means I need to read the specification of the chip 8 and simulate every instruction that it has. While this seems insane, it's actually not that difficult. First of all, the GPU only has like 30 instructions, and they are all super simple. And the other systems were also simple, like the screen is literally a block of memory. The reason this was my favorite project is because once I finished writing the code, I could just load in a game, and it just worked like magic almost the first time. And I can poke around the CPU itself, like I can change the clock speed. And I only had one problem. The binary seemed to be in little endian, so I had to swap bits around. But because the entire codebase is less than 1000 lines of code, I was able to finish it with little problems. My next project, however, won't be this easy, and it is my first ever big game I ever made, a Terraria clone. My final goal was actually to make Minecraft in C++, but I had no idea how to do 3D stuff, so I settled for the next best thing. And it actually turned out to be a great idea to make this game. Not only was I able to participate at a national programming contest with this project, but I also learned so many new things. The only way you can learn how to be a good programmer is to make a big project, because you see hands-on what programming patterns work and when do they work best. And it just so happened that Terraria was a super good choice. Terraria is what I call a skill scaling project, and this means that it starts super easy, but with time, it gives me the opportunity to add complex features. I started this project with just placing some blocks around and implementing a camera, but before I knew it, I was implementing collisions, which were super hard for me to do at that time. If you want to evolve in your C++ game dev journey and you are not sure what to do, just make a Terraria clone and take things step by step. Before we move on to my third project, if you want help from me with this Terraria project, I recently released a course where I teach you exactly that, with 6 hours of video content and 50 plus challenges. And I show you the good programming practices I use. Link in the description if you are interested, and it might have a special offer. Now, the next project is my own programming language, C++. Yes, you heard that right. I made my own programming language, and while it's super rudimentary, like I don't even have arrays, it does work, and I even added a while else statement. While this might seem super hard, it's actually quite easy once you understand how things work. This is called the grammar of the language. It's basically a mathematical representation of your programming language, and once you have it, it's quite straightforward and fun to code it. Let's take a look at an example. Let's take a while statement. We expect the word while first, then we open a parenthesis, and inside, we expect an expression. Now, what is an expression? Well, it can either be a variable, or directly a number, or maybe the word true or false, and so on. If at any point we don't get what we expect, we throw a compile error. This is only one of the steps required to make a programming language. But similarly to chip 8, once you finish it, you can just type in code in your language, and it will run like magic. If you want to do this yourself, search crafting interpreters online, and you will find this very nicely explained blog. Moving on, the next project is my C++ game engine, and this one is split into multiple parts. It all started with my own 2D library. The codebase for this is quite simple, but once I made this 2D library, I couldn't stop using it. To this day, almost all the games I make use this library, including the game I shipped on Steam. So I made more, like this UI library that uses my 2D library and can super easily add a menu to any game. And what comes after 2D? Well, 3D of course. I made a 3D library with the goal of making 3D games in C++, as simple as making games in Unity. But now that I had all of these things, it was time to put them together and make an engine. But there was the problem. All this time, I have been avoiding game engines, because I simply don't like the workflow. I wanted to be able to write my own systems, not be forced to make my game into a pre-made Unity environment. So why would I make my own game engine that is basically just the same thing as Unity? But then, I had an idea to make it completely different. And that's why I always encourage you to try and write code instead of planning too much. By spending all your time planning, you will just make the same thing you have seen other people do. But if you just start writing some code and see where that gets you, you might discover a new way of making things. And that's what I did with my engine. Most people just have an editor, where you have entities and you can place them in the world. In my engine I have none of that. So, what do I have instead? Well, it all starts with a container. A container is just a piece of code that you write, and you can use it to make your game. In this engine, you have to write the game from scratch, but you do it inside this container. So what is the advantage then? Well, first of all, the code is hot code reloadable, meaning you can keep the game running, modify the gameplay code, and it will update in real time. And you can even record the user input and play it back over and over while you recompile the gameplay code, or make a snapshot of the game and return to it. But it gets even nicer, because you can create another container to implement tools for the game, like a 3D model viewer or level editor, all with the exact same API you used to make your game, so they can super easily share the code. And I provide tools to super easily implement all of this. So while my engine doesn't provide a standard 3D editor, it gives you the tools to implement your own editor for your own needs in no time. But with this, there was only one more thing I haven't tackled before, and that was multiplayer. So back in 2021, I started my biggest ever project, making a multiplayer Minecraft clone in C++ from scratch. This was by far the hardest thing I have ever done because of the multiplayer aspect. People think that multiplayer is a feature that you can just add later, in the same way you would add shaders to your game or entities. In reality, if you want multiplayer, your entire game needs to be written with that in mind. Even something as simple as item durability has to be specifically implemented for multiplayer to work, and it is super hard, but one step at a time. I managed to implement it. I even have basic procedural dungeons, enemies with animations, super cool shaders, and the server can simulate each player on a different thread. Similarly to my game engine, I was able to implement the entities in a different way than what most people do. I call it compile time entity component system. I like to implement each entity in a different struct, but that means I need a different container for each one of them, and duplicate a ton of code. So I wrote some weird C++ code that allows me to iterate over every container with the same code. It is super weird, but I only had to write that in a few places. And now adding an entity is super simple. I have a struct for the client implementation, a struct for the server implementation, and a shared behavior that is automatically synchronized. And I can even add special behaviors to entities that will add extra implementations in the server and client code, all at compile time. Now if you like what you saw here, I have many more projects, like a 2D physics engine, so check that out and subscribe to not miss out on future things. And again, if you want to also do cool projects like this, but you are scared to start, check out my game dev course for beginners. 6 hours of video content, just like this one. The course is designed so that you have to implement some features on your own, while I guide you through implementing the core structure of the game. And you also get many bonuses and good coding practices explained hands-on. Check the link in the description and it might have a special discount. See you there.